Sit very still. Hold your breath. You feel motionless, don't you? The ground beneath your feet feels solid. The room feels anchored. But this is an illusion. At this exact moment, the Earth is spinning at 1,000 miles per hour. It is orbiting the Sun at 67,000 miles per hour. And the Sun is orbiting the center of the galaxy at 500,000 miles per hour. But even that is not the full story, because the galaxy itself is moving. We are not floating in a calm ocean. We are caught in a violent current. Our entire galaxy is being dragged through the dark, towards something we cannot see. How do we know we are moving? We looked at the oldest light in the universe. In the 1970s, astronomers analyzed the cosmic microwave background, the afterglow of the Big Bang. It should have been uniform, the same temperature in every direction, but it wasn't. When they looked at one side of the sky, the light was slightly blue shifted, it was hotter. When they looked at the opposite side, it was red shifted, it was cooler. This is the Doppler effect on a cosmic scale. We are rushing toward the blue light and running away from the red light. We realized that the Earth isn't just orbiting, it is plowing through the universe. So how fast are we going? We crunched the numbers. The Milky Way galaxy is moving at 600 kilometers per second. That is 1.3 million miles per hour. At this speed, you could travel from Earth to the Moon in less than 10 minutes. Something massive is pulling us. Something with enough gravity to drag a galaxy full of 400 billion stars like it was a toy boat in a river. We knew the speed, but we couldn't find the destination. Why couldn't we see it? Because we were looking in the worst possible direction. By a cruel cosmic coincidence, the river of gravity flows toward a point in the sky that is directly behind the center of our own galaxy. The Milky Way is full of dust gas and bright stars. It acts like a thick curtain. Astronomers call this region the zone of avoidance. It is a blind spot that covers 20% of our sky. For decades, we knew we were falling. But we couldn't see the floor, because the dust of our own home was in the way. To find the monster, we first had to map the village. We live in a cluster called the Local Group. It is a small neighborhood. It contains the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy, along with about 50 tiny dwarf galaxies. Gravity binds us together. We are currently dancing with Andromeda. In about 4 billion years, we will collide and merge. But while we dance, the entire group is sliding sideways. The whole neighborhood is drifting. We are all on the same raft, flowing down the same river. For a long time, we thought we had found the culprit. Just next door to us, cosmically speaking, is the Virgo cluster. If the Local Group is a quiet suburb, the Virgo cluster is downtown Manhattan. It is a massive city containing over 2,000 galaxies. It is the gravitational anchor of our immediate region. We are undeniably falling toward it. So astronomers assumed that Virgo was the one pulling the strings. They thought it was the end of the line. But when they measured the mass of Virgo, something was wrong. It was heavy, but it wasn't heavy enough. The math didn't balance. Virgo simply didn't have enough gravity to drag us at 1.3 million miles per hour. And then we noticed something even more disturbing. Virgo isn't sitting still either. Imagine you are swimming toward a raft. You are paddling hard to catch it, but then you realize the raft is also moving. We are falling toward Virgo, but Virgo is being dragged away from us by something else. Something much, much larger. We are both just debris caught in a much stronger current. We finally gave this mystery a name. We called it the Great Attractor. It sits 150 million light years away. It is a gravitational anomaly of terrifying power. It is pulling on everything across a region of hundreds of millions of light years. It is the bottom of the basin, the drain in the cosmic bathtub, but for decades it remained a ghost. We knew where it was, but because of the dust in our own galaxy, we couldn't see what it was. Eventually, radio telescopes pierced the veil. What we found wasn't a single object. It wasn't a supermassive black hole. It was a wall. The Great Attractor is actually a massive concentration of galaxy clusters, specifically the Norma cluster and the Pavo-Indus supercluster. It is a dense tangle of thousands of galaxies crashing into each other, dying and merging. The gravity generated by this pileup is immense. But here is the final twist. Even this wasn't enough to explain our speed. The Great Attractor is strong, but not strong enough. In 2005, X-ray telescopes looked even deeper, beyond the dust, beyond the attractor. And they found the true king. The Great Attractor was just a hill. Hiding behind it was a mountain, the Shapley Supercluster. It is 650 million light-years away. It is the largest concentration of matter in the local universe. It contains more than 8,000 galaxies packed into a tight ball. This is the true engine of our motion. The Milky Way, Virgo, and the Great Attractor itself are all falling toward Shapley. It is the monster behind the curtain. For decades, we focused only on the pull. We ignored the push. In 2017, astronomers realized that the Shapley Supercluster wasn't doing all the work alone. Gravity attracts, but emptiness seems to repel. Directly behind the Milky Way, in the opposite direction of the attractor, lies a massive empty region of space, a void. Because it has so little gravity compared to the rest of the universe, it effectively acts like a repeller. It is pushing us away. We are being shoved by the void and pulled by the mountain. This combination, the dipole repeller, is what flings our galaxy through space at such terrifying speeds. When you step back far enough, the chaos disappears. A pattern emerges. The universe is not random. It is structured. It looks like a sponge or a spider web. Astronomers call this the cosmic web. The strands of the web are filaments made of thousands of galaxies. The holes in the sponge are the void's millions of light-years of absolute nothingness. Matter flows along these filaments like cars on a highway, all heading toward the major cities. In 2014, we finally drew boundaries on this map. We realized that our local group, the Virgo Cluster, and even the Great Attractor are all just suburbs of a single massive nation. We named it Laniakea. In Hawaiian, it means immeasurable heaven. It is a structure 500 million light-years wide. It contains 100,000 galaxies and the mass of 100 quadrillion suns. This is our home. This is the continent on which we live. How do you define the border of something that is made of gravity? You think of it like water. Think of a watershed on Earth. When rain falls on the tip of a mountain, if it falls on the left, it flows into the Pacific. If it falls on the right, it flows into the Atlantic. The mountain peak is the boundary. Gravity works the same way. Space has hills and valleys. Laniakea is defined as the region where all galaxies are flowing downhill toward the same gravitational valley, the Great Attractor. It is a river of stars. Every galaxy inside this border is caught in the same current. We are sliding along the filaments, merging with other groups, slowly making our way to the center. We are just a speck of dust, floating in a river of 100,000 galaxies, all rushing toward the Great Attractor. We are part of a grand design that is bigger than we ever imagined. The structure of the universe is defined by the light, but the terror lies in the dark. Between the filaments of the cosmic web lie the voids. These are regions of space hundreds of millions of light-years across, containing almost nothing. The most famous is the Boötes Void. It is a sphere of absolute emptiness so vast that if the Earth were in the center of it, we wouldn't have known other galaxies existed until the 1960s. We would have looked up at a completely black night sky and thought we were truly alone. These are the air pockets in the cosmic sponge, and they are growing. Laniakea is huge. But in 2008, astronomers found something that scared them. It seems that Laniakea and all the superclusters around it are drifting too. They are moving toward a patch of sky between the constellations of Centaurus and Hydra. We call this phenomenon dark flow. The data suggests that something massive, something far larger than anything in our observable universe is pulling on us from beyond the horizon. Is it a megastructure from the Big Bang? Is it the gravity of a neighboring universe? We don't know. We are being pulled by a ghost that lives off the edge of the map. So will we ever reach the Great Attractor? Will we ever meet the giants at the center of the city? No, we are moving fast. But the universe is expanding faster. Space itself is stretching. The distance between the Milky Way and the Shapley supercluster is growing every second. We are running on a treadmill. The finish line is moving away from us faster than we can run toward it. We will spend eternity chasing a destination that we can never reach. This reveals the ultimate fate of the river. In the distant future, dark energy will win. The expansion of the universe will become so fast that it rips the cosmic web apart. The filaments will snap. The river will dry up. Laniakea will dissolve. The Milky Way and Andromeda will merge into a single island. And then everything else will disappear over the horizon. We will be left floating alone in a limitless ocean of black. The story of the Great Attractor is a story of perspective. We used to think we were the center of the universe. Then we thought we were drifting randomly in the dark. Now, we know the truth. We are part of a grand design. We are a droplet in a river of giants flowing through the largest structures nature ever built. We may never reach the ocean, but at least we know which way the current flows.